Thank you very much. Thank you for the hospitality once again. It's really fascinating to see so many Beijing universities. For those of you who were there, as I mentioned this morning, this talk is perhaps fairly demanding. And why? Not because it is technically advanced. No? Is that okay? Not because it is technically advanced, but because I have to take quite a number of steps. Okay? I have to take quite a number of steps to reach my destination. Now, what's that destination going to be? Well, as most of you know by now, we have these various steps to take: semasiological variation, conceptual onomasiological variation, formal onomasiological variation. This morning, we saw one method of measuring formal onomasiological variation and of doing something with that, of trying to see how language structures, or at least the structure of language variation, develops when we look at lectal and lexical variation. So that was a first step in our study of formal onomasiological variation, synonymy patterns, if you wish. What we're going to do in this talk and in the next is to move one step forward and, to a certain extent, explore the interaction between conceptual variation, meaning variation, and precisely the formal lexical variation that we had a look at this morning. So in lecture 8, this lecture, I will ask the question, to what extent do concept features like salience and vagueness or fuzziness influence formal onomasiological variation? So we've already seen that the choice that you have between various synonyms may be influenced by lectal factors, by sociolinguistic factors. But we can also ask ourselves the question, if we briefly look back at this overview, we can say, okay, but what would semasiological variation and maybe conceptual variation and the characteristics that we find there, what could those things have to do with the formal onomasiological variation? So the first lecture is, to what extent do concept features like salience and fuzziness influence formal onomasiological variation? And there is another question to ask, when we have a set of near synonyms, in order to do our formal calculations in the correct way, they would have to be really semantically equivalent. Is that always so easy to establish as what we have with clothing terms and football terms, for instance? So, but that's for tomorrow. So for today, let's ask ourselves the question, how can we measure lexical distances between dialects and determine the structure of a dialect area? So I will now be talking about the dialects in the most basic sense. If you think back of the representation we had earlier this morning, we're now at the bottom level of the pyramid, where we have the local dialects. And specifically then, if we have a look at those things, to what extent should such methods be sensitive to concept features, the kind of features that I just mentioned, like salience and fuzziness? With regard to the first point, my hypothesis, or my claim, if you wish, is, of course, that a profile-based approach of the type that I introduced this morning, taking into account relative frequencies of formal alternatives, yields better results than alternative models. That's something I want to show. Also, with regard to the second point, to what extent should such methods be sensitive to concept features? Well, that's a new point. I will try to make clear that lexical heterogeneity in a dialect area, let's say to have a lot and a lot and a lot of variation in the denomination patterns, is influenced by concept features. Right. The background, I'm going to pass over this because I've mentioned that in the context of other talks. The bibliographical references are largely the same that I already gave you, so this is a point that we can skip. Okay, this is the structure of the talk. I will take a number of steps. The first step is to have a look at the raw material that we will work with. And the raw material is a lot of knowledge that people, that dialectologists, have compiled about a certain dialect area in the Dutch area. As you know, I'm mostly doing the research on Dutch, so again, we will be looking at Dutch. Then I will say something about how to measure lexical distances. That's something we already know. That's what we did this morning. And then I will say something about how to measure concept characteristics. If we assume that there is something like salience or fuzziness effects, how could we measure the fuzziness, for instance? How can we measure the vagueness? And then these two things, measuring distances and measuring concept characteristics, these two have to come together, and we will methodologically join distances and characteristics and see whether our results are of the type that I just predicted, that they confirm my claims or not. So the claims were now let's not go back. Okay. First, the raw data. What are we talking about here? Well, there is one tradition in the linguistics of Dutch where people do traditional dialectological research, and they collect materials on the different local dialects that they found. And we also have, in that context, we have a very, very detailed dictionary of a number of dialects. Specifically in this case, those are the dialects of the Limburg area of the Dutch-speaking area in Belgium and the Netherlands. And within that dictionary, we take one specific volume or chapter, if you wish, from that dictionary, the chapter devoted to the human body. There are some further restrictions here, but they are not so important for what we are trying to do. So what we are looking at here is basically 200 different rural, well, most of them are rural, 200 different dialects situated in mostly villages. And we are looking at those dialects for just over 200 different concepts, all of which have to do with the human body. And that gives us a database. So if we look at the way at how those concepts are being used in the dialects, we get a database of about 32,000 tokens. There is some refinement you have to do. We have to throw out a number of things because the material is corrupted, whatever. So ultimately, we get 172 places, 179 concepts, and still about, let's say, almost 32,000 tokens. This is the area in question. Yes, I've been talking about Dutch, about the Netherlands, and about Belgium a lot. Finally, you get to see a map. This is Belgium. This is the North Sea, right? England is about over here, and this is France. This is Belgium. This white line here gives you the borderline between the French-speaking part of Belgium and the Dutch-speaking part of Belgium. That is the Netherlands, Holland. And then the area that we are talking about is this one. So it's partly in Belgium, and it's partly in Holland. And if you go back to medieval times, before the national boundaries that you see here were established, then this was basically one cultural area. So there is a lot of similarity between the dialects that you find in the Netherlandic Limburg province and in the Belgium Limburg province. The provinces are called the same, right? The province name is Limburg, but one is in the Netherlands and the other is in Belgium. Okay, so that's the basic materials. Now, measuring lexical distances, that's what we saw this morning, but I will go through it and add a few things and also add another example. Because the question that we have here, and that might be interesting if you compare it to what we had this morning, What we have here is a data set which is slightly more complicated than what we had this morning. This morning we had basically only 6 points, 6 lectal points to compare. Belgium in 1990 in the shop windows, for instance, right? Belgium materials 1990, that was one data point, one lectal point. And we only had 6 or 4 or 8 of them. That was quite easy to represent in diagrams. But in this case, we have 179 points, villages with their own dialectal or dialectological, at least, characteristics. So we will need special ways of representing this. We have to go one step beyond the methodology we had this morning. How can we do that? Well, we have to take a number of steps here. We have to measure the dissimilarity between 2 places for a single concept. We've seen how we do that. We have to take into account all concepts. We've also seen how we can do that. And then, and that's the new thing, we would, taking into account all places, we have to analyze the structure of the variation in that geographical area. Okay, let's go through the steps once again. Measuring the lexical similarity and dissimilarity. Okay, in principle, I say here we will compare 5 different lectometric methods. I mentioned one this morning, okay? There are more. There are ones that are not profile-based. I say we will compare 5, that is to say, in the final pictures that I will show to you, there are 5 methods, but basically I'm only talking about 2 different methods. The one I presented this morning, the profile-based one, and one that was developed by an Austrian dialectologist, Hans Goebel, and I will mention in a moment where the difference is. So let's remind ourselves what the profile-based method implies. Well, let's take an example, and this time not football terms or clothing terms, but Maggie Thatcher, you know, the former Prime Minister of the United Kingdom, whom you all know. But there are different ways of naming her, of referring to her. You can call her Mrs. Thatcher. She was also known as the Iron Lady. She was also known, quite disparagingly, as Attila the Hen. Okay, this is, of course, a pun. You have Attila the Hun and then Attila the Hen. And you could possibly call her Maggie Roberts, because that was her maiden name. So you have, let's say you have 2 newspapers or whatever, 2 samples, and you have the different references. What's our profile-based approach to remind you of this? Well, we start from the onomasiological profile, the relative frequencies of the different names. These would be the profiles for the material that you saw a moment ago. And on the basis of that profile, we calculate the overlap. So we determine the relative frequencies of the elements in the profile and calculate the total overlap between the relevant frequencies. So in this case, between the 2 sets of terms, that would be an overlap of 85%. Fine. Now, what does Goebel's method do, starting from the same material? So you start from the onomasiological profile for a given concept in the 2 samples, but you reduce the 2 samples in a different way. Namely, you look only at the most frequent term, the most frequent element in the 2 sets, and then you say, okay, there is difference or there is no difference. Obviously, that's more simple and simplified than the profile-based method. There is a nuance that I have to add. But it's not so important for what I'm showing, but just to do justice to Goebel, there is, so this is what I already said, there is a nuance to the extent that uniqueness of terms across all samples may be a weighting factor in calculating similarity or distance. But as you see, it's not really profile-based. It's much more simplified, much more reductive than a profile-based method. Okay, so that's the first step. You have 2 similarities for a set of concepts in 1 point, or at least for 1 concept in 1 point, and you measure a degree of overlap, profile-based or not. Then you take all the concepts you're looking at, the 170, what was it, 179 in this case, and you average. and you can have a weighted average or not. That's also something that we saw this morning. And then step 3, and that's a new thing. That's, apart from Goebbels' method, that's the first new thing in this talk. How are we going to present that in a single chart? Okay, that's the difficulty, because we have this 172 points. It's much more difficult than earlier to draw lines between all the points. You can't just say, okay, and from there to all other 171 cases, that type of similarity, that degree of similarity, that degree of... That's not possible. That doesn't give you an overview. So we apply a statistical technique here. We apply a multivariate analysis and specifically a so-called multidimensional scaling of the variation that we find. And when you do multidimensional scaling, you get an indication of underlying dimensions that structure the variation. The dimensions are not identified. Okay? It's not like saying you have a dimension that has to do with whatever aspect of the human body in this material. That's not the case. It's a statistical measure, the dimensions that you get. But it's a statistical measure that you can use to get a clearer view of the variation in your material. And usually in a multidimensional scaling with 3 dimensions, you already get a very good idea of how the variation is constructed. And the interesting thing is that when you have 3 dimensions, you can still represent them graphically in a 2-dimensional space. Okay, this is one page is 2-dimensional. You can represent them in a 2-dimensional space by using extra tricks, if you wish. And the trick that we will be using here is to add color. Now, how can we add color? Well, we can visualize the results of a multidimensional scaling by linking each of the dimensions of the 3 dominant dimensions that we find in the statistical analysis with a certain color. So the statistics tells us we have 3 underlying dimensions, and then we say, okay, program, this is very good, but now we want the first dimension to appear as red, and the second dimension as green, and the third dimension as blue. Okay? And we then have a value for each dialect each data point in the variation. For each dialect, we have its position on the 3 dimensions. That's what the statistics gives us. But we also have, or we can translate that position into a color, because we can say, for instance, take a data point that is 80% red and 50% green and 10% blue. Well, then you mix those colors to that extent. You just take pure red and pure green and pure blue, and you mix them for 80, 50, 10%. And then you get a specific color for that data point. Okay? Now, I'll have a look at this. This is probably too abstract, but have a look at this geographical map. And this is what results from this type of analysis. Okay? This results from the analysis by saying, so each point here is a dialect, okay? And each dialect has a specific color. And the specific color comes from using the technique that I mentioned a moment ago. Now, what's interesting about that is that you can see that there is structure in the data, because the point here is, obviously, when the colors are similar and when they appear in the same neighborhood, then you have a geographical structure. Then you can say, okay, what do we see here? Here we have blue colors, and they go to green over there like that, and then they go to more purplish ones. Okay? What does that show? Well, that shows that if you bring together the similarities and the dissimilarities between all these dialects, then it's not random. They don't all have the same color. There is structure, and it's geographical structure. Because this thing here, oh yeah, maybe I should have said that. So this is the Belgian province of Limburg, and this is the Dutch province, the Netherlandic province of Limburg. So what you can see is that there is indeed at least a separation between the Netherlandic province and the Belgian province, because there is more blue over here and there is more green and red over there. Okay? So this is a way of finding structure in this much more complicated data set. Okay? The similarities, the geographical similarities, can be plotted on the map. You're still with me? Yeah? Okay. Keep this in mind. We will be coming back to this in 30 minutes or so. Now the second step. Oh yeah, perhaps just to go back to get a clear idea of what the question is here. So these are similarities that are calculated on the basis of a profile-based method, right? And we do find some lectal structure in here, because we can say this is the Belgian Limburgish dialects, that's one big lect, and the Netherlandic Limburgish dialects, that's another lect. So we find lectal structure. We find a correspondence between the similarities and dissimilarities and a geographical map, a geographical outline. But the question we are asking here is, if we have that, what is the influence of concept characteristics on this type of structure? Would we find the same type of structure? Would this type of structure be clear or clearer for some concepts than for others? Could it not be the case that part of the underlying idea with this type of structure is what determines the structure is the difference between language varieties, the difference between lects, a social thing. But the question I want to ask is, could it not also be the case that the variation is determined by the kind of concept you have? And if we then know that some concepts are more likely to exhibit variation than others, then we may perhaps filter those concepts so that we get an even clearer idea of what the underlying lectal structure is. So if the variation is determined by different factors, some of which could be social and lectal, and others which could be conceptual, then we would want to filter out the conceptual factors. That's what we're trying to do. How? Well, first the question is, why do we have that idea and how can we determine those characteristics? Fine. Okay. Well, lexical dissimilarities of the type that I just mentioned may be influenced by concept characteristics. Why? Yeah, this is what I just said. Let me go to the following one. Well, think of salience. Think of the fact that a concept may be more clear in the mind of speakers than other concepts. For which type of concept are we likely to find most variation? Well, the unclear concepts may show a lot of variation in the data precisely because people don't know them very well. Okay? So we might want to see whether less familiar concepts are indeed more likely to be subject to lexical heterogeneity, that is to say, lack of structure, just a lot of variation without a clear lectal structure, than the more salient concepts. It's a hypothesis. We don't know, but it's a hypothesis that we might want to take into account. Similarly, some concepts may be vague, may not have clear boundaries, may not be quite distinct in the mind of the speakers. It's not so uncommon to think that when you have a vague concept, it might be subject to more lexical heterogeneity, to more random variation than concepts that are not potentially confusing. So we might want to see which concepts are vague. And also, we get, specifically also in the area of the human body, we get a lot of concepts that are taboo-laden, that have a negative connotation. And it's also possible that it's perhaps even likely that concepts with a negative affect, with a negative emotional overtones, are more lexically heterogeneous than concepts that allow more open communication, that are not taboo, for which you don't need euphemisms, for instance. So what we would need to do is to establish whether things like salience and vagueness and negative affect influence the variation that we have. Okay? That's what we're doing in this step. Now, in order to do that, we need to be able to measure salience, vagueness, and negative affect. We have a number of criteria that we use for that, but this is a part of the talk. You'll find it in the handout, but it's a part of the talk that I will go over very quickly. Let me perhaps just give you 2 examples. So what I've done here is to say we are using 5 indicators of the criteria that I mentioned. We are using lack of familiarity, observational gaps, and multi-word answers as indicative of salience. We're using lexical non-uniqueness as indicative of vagueness, and we're using negative affect as, well, a measure of itself. I won't go into the way in which we implemented these characteristics. I won't do that because it would be getting too complicated. But just briefly, so when we have that, we'll ask ourselves whether these things influence heterogeneity. So, for instance, for lack of familiarity, the reasoning is that concepts that are less familiar increase the risk of uncertainty among language users, and so reduce the chances for uniformity across users and dialects. Okay? So less familiar concepts are likely to show more heterogeneity. Okay? But we would want to know what the less familiar concepts are. One way of doing that is simply to ask people. We have other indications of salience, lack of familiarity, but one way of doing it is just to ask people. So we did a very, very small-scale survey among the members of our research team and asked them to score a number of concepts and tell them whether they were familiar with the concept or not, whether they thought the concept was an everyday concept or not. And so on a 5-point scale, 5 would be probably rather unfamiliar and 1 would be an everyday concept. So the results that you get, well, some of these might indeed be offensive because you get a number of taboo areas here. But think of this thing. Take my hand, okay? This thing between the knuckles, okay? These are the knuckles, and between the knuckles you have this little dent, okay? Is that a familiar concept? Well, you know the thing, but you would hardly ever talk about it, okay? So that's the question we're asking. You may know the thing. You know, well, we mostly know our bodies, but is this a familiar concept? Well, no, probably not. On the other hand, if you take throat or knee or middle finger, those would be familiar concepts, right? So we have, when we do that survey, we have a scale of familiarity of concepts. And we did something similar, not always with surveys, I want to add that, not always with surveys, but also by exploring the data itself, the type of material in the dialectological dictionary itself. But to go to the final one, to go to negative affect. There, for instance, we had 2 indications. In some concepts, for some concepts, the dictionary itself mentioned that it was a negatively connoted concept. So there we had the authority of the dictionary, if you wish. And that would be the case, for instance, when it was when the dictionary mentioned that certain names for the nose would be pejorative names, like names for an ugly nose, if you wish, or which you want to express that people have an ugly nose. There are also other types of taboo items which clearly come out of the survey, like for fat people and so on. All of this is not really the most tasty part of the talk, so we'll move through that. Okay, so we have these indications of characteristics of the concepts. Okay, we know that, or we think that we have things that point in the direction of salience, familiarity of the concepts, things that point in the direction of vagueness of the concepts, whether people know very well what is meant by the concept, and we have indications that point to the negative overtones, emotionally negative overtones of the concepts. And now we want to ask ourselves, do those characteristics in fact influence the lexical heterogeneity that we find? The amount of variation. Okay, new problem, next problem. How are we going to measure the amount of variation? Geographical variation. It's important to say that. Geographical variation in the dialect area. Well, we took two indications of geographical variation. We said when we have variation in this geographical dialectological material, we will have many different words for one concept. That's a form of heterogeneity. Many different words for one concept. Okay? That's what I call here lexical diversity. The existence of different words in the total Limburgish area, in this case, the existence, not in one lect, in one specific dialect, but in the whole area. Many types, right? Many word types for one concept. That's a form of heterogeneity. And you can imagine that for instance, I think that is intuitively clear when you have a taboo item, a taboo concept, you often get very, very many euphemisms. Okay? So that's the type of lexical diversity you can expect. If something is negatively connoted, you probably get very many different words of avoiding the connotation. That's an example of lexical diversity. We also consider the geographical distribution of the items, and we can say, okay, we have lexical heterogeneity when the different names are spread out unevenly over the geographical area. Okay? And that's what we call geographic fragmentation. When the items are scattered, when they're not clustered into clear groups, then we get heterogeneity, geographic heterogeneity. And then the measure of heterogeneity taken together is simply the product of diversity and fragmentation. Am I losing you? No? Okay. So what we now have in the second main step of the argument is this. So the first main step is we have ways of establishing lectal structure by using a profile-based method. The second major step is, do we have indications that concept characteristics might influence lexical heterogeneity? Yes, we have indications, or at least we're about to get them. That's what we're going to show now. And in order to show that, we have to link our concept characteristics and our measure of lexical heterogeneity. And we have to prove that indeed the concept characteristics that we identified influence this measure of lexical heterogeneity. Okay. How do we do that? Well, here we bring in another statistical technique. We bring in a regression analysis. A regression analysis of the material we have here, and in this case we use a multiple linear regression where the response variable, so what we try to explain, is heterogeneity in the definition that I just gave, the product of diversity and fragmentation. And the predictive variables are then, obviously, you can expect that the concept characteristics like vagueness and salience that we introduced earlier. So this is what we just saw, right? This is what we introduced. Number of observational gaps, lack of familiarity, proportion of multi-word answers, co-occurrence in other concepts, negative affect. As I said, I didn't introduce all of them. I had a look at lack of familiarity and negative affect. But the other factors go in the same way. So what you get when you do the regression analysis is a thing like this. Most of you are probably not familiar with regression analysis. So let's just look at the important aspects of what this type of analysis tells you. So you have here the five features, like negative affect and lack of familiarity. Okay? And what you get here, the estimate, that is basically an indication of the extent to which those factors actually influence our heterogeneity, what we try to explain. Now, of course, as you know in statistics, it's not just about measuring things, but it's about measuring things that are significant, that are statistically significant. Now, whether these factors, whether these effects are statistically significant, that's something that you can see here. Because that gives you the 3 stars, or the stars give you the degree of significance of the effect. And as you can see, 3 stars, that's a high degree of significance. Because as most of you will know, the regular cutoff point for statistical significance in linguistic studies is, well, in this notation, it's 1 star. So when you have 3 stars, it's really significant. So we have a reliable result. So we get, that's what I say here, excellent p-values. That in this case, that means 3 stars. Okay. Other things that we see is what is called a good adjusted R squared. In fact, that means how much of the variation in the heterogeneity measures that we find, how much of the variations in those measures can we explain by looking at those 5 factors? Well, we can explain almost 62%, so that's a good result. It means that there is a fairly strong effect of those factors on the heterogeneity. And we also see that, in fact, all 5 of the factors that we looked at do have a significant effect, and a highly significant effect. So our initial intuition that these factors might influence the heterogeneity is correct. The statistical analysis shows that there is a clear effect on heterogeneity. This has important consequences, right? This has the consequence that we more or less took as a starting point for this complicated talk. Namely, that when we want to measure, when we want to reveal the lectal structure in the profile-based variation, then we might want to filter out the effect of these factors, the effect of the concept factors. Okay? And now we see that indeed concept factors of this kind tend to blur the lectal structure, because lectal structure is less heterogeneity. Lectal structures is when you can clearly see these items are in that province, those items are, or that type of variation is in that province. Right? That's the lectal structure. That's less heterogeneity. In this case, we can already establish that there is an effect of concept characteristics on heterogeneity. So the next step is, can we filter out the concept characteristics to get a clearer picture of the lectal underlying structure? Okay? How are we going to do that? Well, that will mean joining characteristics and distances. How much time do I have left? Okay, it's okay. So, we want to know how lexical variation structures the dialect landscape, but we want to be careful with lexical variation that is influenced by concept characteristics rather than just lectal structure. New methodological problem now. How can we establish that? Well, we need 2 things. First, well, let me start at the bottom here. First, we need a way to filter the profile-based calculations on the basis of the concept characteristics that we have. But given what we did this morning, I think you can understand how we can try to do that, because we can do that by giving a weight factor to the results of different concepts. So if we have a concept of which we know that it is highly heterogeneous on the basis of the regression analysis, on the basis of its concept characteristics, then the results for that concept will play a smaller role in the calculation of the overall, of the average. You remember that we average over various concepts, but if we have a concept that scores high on the heterogeneity analysis, then that concept will have less importance in measuring the average. It's the same what we did this morning with the bowler hat, where we said when we look at clothing, we might want trousers to be more important in the average than bowler hats. In this case, we say we will want concepts that are conceptually heterogeneous to be less important than concepts that are lexically not heterogeneous, that do not influence heterogeneity. So that's the second point. That's easy enough because we've already seen this morning how we do that. The other point is, okay, you can claim that you want to filter out the effects, and we can see how you might want to do that, but how can you prove that it works? Well, there you need some kind of validation, right? You need a standard to compare the results to. What we will want to do is compare filtered results with unfiltered results. Results where we apply the weight measure with results where we do not apply the weight measure. But on what feature are we going to compare them? What will be our standard for comparing them? Well, let's have a look at that point. Basically, we have two criteria for measuring success in this case. One criterion, but I'm not going to go into that because it is technical, but I do want to mention it because we've used it. The criterion is what is technically called as the stress of the multidimensional scaling analysis. So remember that we, in order to arrive at this type of figure, we do a multidimensional scaling analysis. Now, one of the statistical properties of a multidimensional scaling analysis is a phenomenon that is known as stress. And we can use the stress of the multidimensional scaling analysis as an indication of its success, if you wish. So that's one thing we're going to do. But if you're not familiar with the statistics, it's not so important, but I do have to mention it. The other thing, which is intuitively more clear, is that we might want to compare the results, the lectal results that we get, because we get results saying on the basis of a filtered, weighted, profile-based method, these are the areas that you can distinguish. Okay? So how good is that result? Well, one thing we can do is to compare the result in question with existing classifications of the area in question, because that's one thing that dialectologists do. Dialectologists don't just record and describe things. They also try to find structure with their own methods, not our methods, but with their own methods in the geographical area. And what we will do then is to compare our results with existing classifications, existing sub-classifications, so to speak, of the Limburgish dialect area. And fortunately, that's one of the nice things here, of course, is that the dictionary from which we took our raw materials has its own classification. So its own classification. The interesting thing is that these traditional dialectological classifications are very often based on purely formal features, like correspondence in pronunciation or correspondence in morphological or syntactic features, and much less so on correspondences in lexical features. So in a sense, we're trying to see, this is a bit of an exaggeration, but in a sense, we're trying to see whether we can simulate the results of a non-lexical traditional classification with a lexical classification. And the dictionary then, and that's another thing that's important for the charts that I will be showing. The dictionary, or in general, you can divide this dialect area on different levels. The first level we already know about. That's the level where you have the Belgian province and the Netherlandic province. Okay? So that's clearly a classification. There's another classification where we have 10 traditional regions. You can think of them as counties, for instance. 10 counties. And then even within that, even smaller areas. So we have an existing classification at 3 levels, and we can see, or in our results, to evaluate our results, we can see which of our results corresponds most closely to one of those existing classifications. So we'll do that on 3 levels, and then fortunately we will be able to say at the end of the talk that the weighted calculation, the filtered calculation that we propose is the best approximation of the existing classifications, and in fact on all 3 levels. So to briefly indicate how we can then measure the correspondence with a given classification, because that's the next methodological step we have to take. So we needed a standard, a validation point, but we also need a way of comparing our results with the validation point. Let me not elaborate on this too much, but in essence, what we try to do is this. We take an existing classification, and an existing classification is a grouping of dialect points, yeah, right? If you say, this is the province, this is the Belgian province, that means that you know which villages belong there. Okay. Now, if you have those villages, then we can take our results for those villages and see whether they are very similar among each other, what the distance is among the points in the grouping, and compare that to the distance with the points outside of the group. Okay? And when we compare those distances, so let's say the internal distances within the province with the external distances outside of the province, right? Then we have 2 measures, 2 average distances. And we can compare, or we can take the proportion of those 2 distances. Okay. So, imagine that you have all the neighborhoods in Beijing, and you see how linguistically similar or lexically similar they are to each other. And then you compare them to all villages in a periphery of 50 kilometers outside of, or 100 kilometers outside of Beijing. And you assume that that is an existing difference, right? Beijing is to some extent at least a system on its own, and then you have a rural area, a rural periphery. You take the distances within Beijing, and you take the distances of the same point with regard to the villages in the periphery. And you divide one by the other. Now, if your proportion is near to 1, it actually means that there is not a lot of difference between what you find inside Beijing and what you find outside. Okay? If in this case, the average similarity between the villages in Belgian Limburg is 80%, and the average similarity of those same villages with villages in Netherlandic Limburg is also 80%, then you don't have a distinction. Then you don't have a distinction between the Belgian province and the Netherlandic province. So when the measure that we have when the distance ratio equals 1 or nears to 1, the internal and the external distance is the same. That is to say, the region is difficult to distinguish from other regions. But our point is precisely to distinguish, right? Our aim is to say, can we distinguish in such a way that we can see that it is a region on its own, as the traditional classifications say. So what you have to remember here is that if our distance ratio is smaller than 1, then internal distance is smaller than external distance, and the specificity of the region is recognized. So the measure we use, that's practically the important point for interpreting the charts that will come in a moment. The smaller, the better. Okay? The result is better when the figure we get is smaller. Simple point. And how do we take into account concept characteristics? Well, that's what we've already explained. That's by using a weighting algorithm, a weighting method, by saying concepts that are conceptually heterogeneous in the way in which we analyzed it with the regression analysis should count for less. That's the weighting factor. So what we will now do is to compare a number of calculations. A number of calculations of, so getting back to the first step, okay. We will now do our profile-based analyses. So we will again be looking at, or we will be doing this, the thing that led to this picture. But we will do it now with a number of additional steps, or additional factors at least. One calculation will be the one without any weighting, without taking into account concept characteristics. Another one is using the weight factor as just defined, and that is where we expect to get the best results, better results than without weighting. And then there is another one which we introduce in a sense just for fun, that is to see, we use the inverse of the weight factor, and that's a measure for which we expect the identificational success to decrease. It will, with the third one, it should be less, the success rate should be less than in the factor without weighting. So let's go to the results. So again, we can draw maps. And the maps that we can draw intuitively, that's already an interesting observation in itself. The maps show intuitively interpretable results. Remember that I said we do a multidimensional scaling analysis, and the multidimensional scaling as such does not give you, it gives you dimensions, but it does not interpret the dimensions. Now, when you look at the maps and you can intuitively interpret the dimensions, then you can say, oh yes, that makes sense. The multidimensional analysis does make sense. It makes sense that we do this because we can see the structure. So in this case, it's roughly the case, but that's only through visual inspection. It's roughly the case that the first dimension that we find in the evolution of the colors on the map, because that is obviously what it is about. Do we find structure in the distribution of the colors over the map? The first dimension seems to correspond to an east-west dimension. The second one to a north-south division, and the third one to an east-west division. Okay, which means that there is indeed geographical structure. And we can linguistically make sense of that in the sense that the north-south distinction corresponds to the distinction between Netherlandic Dutch and Belgian Dutch. The east-west dimension, which is represented by the multidimensional scaling dimension 1 and 3, the east-west dimension is the one that traditionally distinguishes let me put it differently, that is traditionally structures the Germanic language area, because what do you have to the east? Germany, right? And these are provinces that are close to Germany. These are, in fact, the easternmost provinces of the Dutch language area. So Dutch and German are related, and apparently the internal structure of the Dutch dialects reflects something of the presence of Germany, of German as a language in the East. So it makes sense. It makes sense. North-south, that's a political division. East-west is a traditional linguistic division. I'm showing a few maps now. This is the map that we already saw with the overall structure. So what it says here is that we show the three dimensions, the three dimensions coming out of the multidimensional scaling at the same time. And here you can already see that you have east-west, that's it. And then if you look within this, within the eastern part, you see that there is also a north-south dimension. That's already clear. This is only the first dimension, and that's clearly one that corresponds with the geographical division and the political division. Belgium, the Netherlands. This is the second dimension, and the second dimension is a north-south one, because the green band is in the south in both provinces. Okay, so this crosscuts the previous one. And the third dimension only is again rather east-west oriented. So on the basis of these results alone, we can indeed see that we get fairly clear structures. But that's not yet the calculation that we wanted to make. Oh yes, now the calculation that we wanted to make is then based on, is primarily based on this division of the area. I mentioned that in connection with the original dictionary in 10 basic regions. Okay, so we'll now have a look at the identificational result for these 10 regions. How good is our lectal method in recognizing these 10 regions which have been traditionally, or which have been identified by the dialectologists on the basis of traditional methods of classification? Okay. Well, we will show that with yet another technique, but this is a very simple one, technically speaking, a scatter plot. And scatter plots is something that you probably know about. You have two dimensions, and you have several points that have a value on each of those two dimensions, and then you plot one dimension with regard to the other. In this case, what are the dimensions? Well, the dimensions are precisely the two indications that we had of identificational success. So you remember, I'm going back to this, that we said, what are our criteria for distinguishing identificational success, for seeing whether we correspond to an existing classification? Well, one criterion of success was the technical one, the stress of the multidimensional scaling, and the other one is then the ratio between the internal and the external distance calculation. You remember this thing, where I said, remember that the smaller the figure, the better. Okay, so now let's look at the results. These are the actual results that I wanted to arrive at. And let's do that for two questions. The first question is, so I will show the same plots, the same scatter plots twice. Okay. The first question is a weighted calculation a calculation where we filter for conceptual effects, for conceptually induced heterogeneity, is that a calculation that gives us a better lectal structure, a better lectal solution than an unweighted calculation? That's the first question. The second question is then if we do the lectal analysis according to Goebbels' method, which I briefly introduced in the beginning, is that giving us better results than if we do it on a profile in a profile-based way? And of course, we will want to claim that the profile-based approach is better. So in this case, I hope this is you can see this. Weighting measure. And remember that we said we expect the weighted measure to be better than the non-weighted measure, and we expect the inverted weighted measure to be worse than the weighted measure. These are the two dimensions, the stress of the multidimensional scaling, but that's not so important. Important here is this measure, which gives us the identificational success in terms of the ratio between internal and external distances. And as I said, remember that it's better, the success is better when the figure is lower. So what we should see is that that overall the W dots are better placed along that dimension than the other 2 points. Let's look here where you get the best results. The lower on the dimension, the better the results. For the green points here, you can clearly see that W is better than N and N is better than I. Take the black points. Again, you see W is better than N and N is better than I. So we've made our point. We've shown that using a weighted measure, that filtering for conceptually induced heterogeneity is giving us better, more straightforward lectal results. These, as I also mentioned, we do this on 3 different levels, starting from a classification in provinces, starting from a classification in 10 regions, and then starting from a classification in 20 sub-regions. So the first plot is, you can see that on top, the first plot is for province. The second plot is for region, but you get the same results. Take the green points, W, N, I, it's the same pattern. And take the sub-regions, the even smaller classification. Again, it's the same thing. Take the green points, W, N, Y. So for the 3 types, for the 3 standards that we could use, the 3 classifications that we could use as our point of comparison and validation, we find that the weighted measures always contribute to a better success. Now let's take the other question that we could ask. Namely, is the profile-based method for measuring lexical distances, is that systematically superior to the other methods? You will remember that I said in the beginning that we compared 5, but that I'm looking at only 2 of them. So specifically, can we say that it is better than the Goebbels method? Now, in the plots here, our method, but you will have understood that by now, is the green one. That's PR for profile-based. And the Goebbels method, that's this one, BCW. Well, basically we have a number of variants, but let's take BCW. And you will always see that the green approach, so to speak, scores better than the red one. So the ones we want to compare here are green and red. So profile-based approach is here for province, okay? The Goebbels approach is over there. In this case, it's the same, green here, red there. And for the sub-regions, it's also the case that we see this and then that. So overall, what can we conclude? Well, let's get back to our research questions, the questions from which we started. First, in general, what is the best method to measure lexical distances between dialects and so determine the structure of the dialect area? Well, we have indications that a profile-based method that takes into account the relative frequency of onomasiological alternatives yields better results than alternative methods. Okay? And the second question was, to what extent should such methods be sensitive to concept features? Well, we have fairly clear indications that lexical heterogeneity in a dialect area is influenced by concept features. An adequate picture of lexical similarities and dissimilarities requires disentangling lectal structure from concept-induced heterogeneity. And I'm now faced with the strange conclusion that the most difficult talk has also been the shortest one in this series so far. Thank you.